All right. Well, welcome everyone. I know people are going to start joining and filtering into this room, but we want to take as much time as we can with this hour we have together. It's August 14th, 2020, and we're gathered here virtually today for our virtual ranch field day. We have Spencer and Brianna will be our speakers, and they'll be telling us about the Healthy Soils project that they're doing on Springs Ranch. It's a 3-year project. I'll be your host. My name is Abby Smith, and I'm with the Jefferson Center for Holistic Management. So let's jump in. So again, to orient ourselves to our topic and give some background and overview, we always do this virtual ranch or this ranch field day, usually the first weekend in June. We open up Springs Ranch, which is the demonstration site for the Jefferson Center for Holistic Management, and we invite everyone to come and see what we're doing on the ranch, to take a walk in the fields with us. We show our grazing plan. Spencer will share, how the grazing plan is going and the impact that it's having. We have rich conversations. We're very open about it. We get some shovels out and we dig around. We look at dung beetles, and it's a fun day on the ranch. But of course, this year with the pandemic, we weren't able to do that. And so we thought, how can we still share what we're learning, but do it virtually? And so how we decided to do it is divide what we would have said to you in person into 4 different videos that cover different portions of the study that we're doing through the Healthy Soils program. So there were 4 videos that are sent out. They're listed here, they're linked. And so everyone who participates today and who registered will get a PDF of this presentation, and then you have those links in there, so you can always go back and watch them. So what did we talk about in those videos? We're gonna cover that, but first I just wanted to get a little bit of housekeeping out of the way. So we only have this hour here together to have this conversation, and we wanna make sure that we use it to the best of our ability. So if you have questions that come up, please use the chat function in Zoom to post your questions, and I'll be watching that, and then I'll surface those for Bree and for Spencer. And then if you could please just mute and turn off your video. Most people have already done that while we're here, so we're not distracted by that, or there aren't dogs barking, or all those fun things that we have now that everyone's on Zoom. And then please do ask questions. This is about conversation. We miss you guys. We wish that we were with you in person, and we want you to feel comfortable and in a nice, safe space to ask questions. And don't worry if they sound silly. Please, we want them. I want to introduce you first to our speakers. This is Bree. She's our neighbor and our friend, and she's also a very talented biologist with Point Food Conservation Science. We feel really lucky to have her as a partner in this work and spend time with her out in the field, counting dung beetles and looking for birds and getting super excited about things like that. If you want to read more about Bree, you can go to the Point Food Conservation Science website and read all about her amazing accomplishments. And then this is Spencer. He is a savory field professional and an EOV master verifier. EOV stands for Ecological Outcome Verification, and it's the monitoring protocol that the Savory Institute offers to farmers and ranchers that allows us to have actual data-backed information about the regenerative outcomes that we're creating on the land. So it's not practice-based, it's outcome-based, and it's a very specific protocol that we've been part of since its inception. So Spencer spends a lot of time out in the field, right at that soil surface, which makes this project really applicable and really exciting for him. So this is our study, just again to orient ourselves to it, and I'm not sure if everyone watched the videos, but just wanted to give a quick overview of what the study was about. So I'll turn it over to Bree as the lead researcher to tell us more about what this study entails. So Bree, do you want to help us with that?
Sure. To start, we designed this study and applied for funding through California Department of Food and Ag that offer a great healthy soils demonstration grant. And we got that in 2018. And so we started our baseline measurements in August of 2019. So we're just completing year one. And there are a whole lot of different things we wanted to look at. And CDFA had a subset of practices, of NRCS practices, that they were interested in finding more about how it affects soil health. And so we thought with the grazing system at Springs Ranch, it'd be really cool to look at compost application, and then also interseeding with different cool season and warm season grasses and forbs. And then also doing some plots with both compost and interseeding. So we have, all of our study plots are about 3 to 5 acres, and we have 3 different replicates of them. Do you want me to go into the different metrics that we're looking at right now?
I think so, Bree.
Okay. So the couple things that CDFA are really interested in is they really want to look at our greenhouse gas emissions. So we are doing that. And then also our soil organic carbon. So we're looking at that at 2 different depths. We're going to look at 0 to 10 centimeters and then a deeper 10 to 40 centimeters depth. We also just are interested in general soil health metrics. So we're are doing the Haney test and then the PLFA that looks at the bacteria to fungal ratios. And then we also ultimately want to look at like the financial impacts of all these practices that we're implementing. So with that, we're also going to look at our crop yield, so production data. We're going to look at a plant tissue analysis. So we're taking, at the same time we're collecting the production data, we'll send a sample of plants to be analyzed at World Labs. And then we're also going to look at the biodiversity on the land. So we want to look at, is anything we're doing affecting our bird populations? And then also dung beetle population as well. So we're looking at a whole lot of different metrics, but yeah, we kind of wanted to make it a well-rounded study. So we're looking at a lot.
So Bree, my friend Anne asked, does that analysis include SAP analysis?
Yeah.
What is that? SAP. Spencer, can you expand if you know what that means? And I can.
Well, I think Anne's asking if the leaf tissue analysis that we sent off, what was, how were they looking at that? And yeah, so they take it, we didn't collect just the liquid portion, but when Bree collected all of that, she collected that and immediately sent it off to Haney so that we knew exactly, because oftentimes your soil test will tell you what mineralization is happening in the soil, but it won't necessarily show you what plant available nutrition is there. And so, or vice versa, right? It might show you that you're low in nitrogen, but actually your plants have adequate amounts if the soil biology is adequate to mineralize that nutrient plant needs. So we did both. We took a tremendous amount of soil samples at different depths, as Bree mentioned, sent those off to figure out what was currently there, and then captured on that what's happening with leaf tissue analysis and then the sap or the phloem in terms of what true mineralization is happening at that interface in the rhizosphere between all the critters in the soil that are unlocking the potential for all those plants. Truly what we're wanting to see is how that delta is going to shift between our 4 different study plots, like Bree mentioned, replicated 3 times over time. So we knew what that baseline was. And then this year we took more data and you know, we really won't be able to see or have a whole lot to share about that until we've got the 3 years worth of study done, so that we can say, you know what, gosh, you know, the compost may not have really shown a whole lot of potential in terms of biodiversity or forage growth, but look at how it unlocked the potential for soil microbiome to create mineralization. So that's kind of where we're at. And this, you know, we don't truly know what's going to happen. I mean, you know, I don't know which of these, and that's what's really exciting about being a part of a true scientific project like this, is
oh, sorry, I think we're picking up some background noise. We want to make sure everyone's muted, please, so that we don't pick up background noise. Go ahead, Spencer. I think we fixed it.
Okay, I might have lost my train of thought, but yeah, the point is that super excited to better understand over a 3 to 5 year time period how the actions that we take today are going to not only increase ecosystem services, but also, you know, forage production and the quality of that forage that is being produced. With further looks at biodiversity, you know, birds are a huge indicator. Bree would be definitely the person to ask that question about, as far as why are birds important to watch. And then dung beetles are, you know, a keystone species in all of these terrestrial or grassland landscapes that have compounding and cascading benefits. So we want to see how these different management techniques are going to increase both overall numbers and diversity. And we don't, or decrease, we don't know if, you know, we just don't know what's going to happen.
Just a quick tech piece. Spencer, if you could stay forward and close to the microphone, it'll help with our sound quality, and same with Bree. We're getting some good questions in, so I want to keep going and make sure we address those questions at the right part of the topic. Is there anything else you both want to add about the overview of the study, the general parameters of what we were doing? Or what we are doing and just starting to do?
I'm good.
Yeah, that's good.
All right. So this was us last year. So imagine that we're all gathered here at Springs Ranch. It's a nice spring day. It's not hot in the middle of August. And we're having this rich conversation about what you're seeing and what you want to know about on the ranch. So this is the time to have the conversation and ask those questions. So what we have next is questions that people submitted. And then there's some that have come in the chat that I'm going to log in the right place. So if you do have questions, please do put them in the chat and we'll make sure that we cover them if possible. So our first video looked at the study overview, which we just covered, and then it looked at the use of the technology of a no-till drill, interseeding with cold season seeds, for lack of, or forbs and grasses. So we have two questions that came in earlier, and I want to make sure we address those. So one came from, again, our friend Anne, and she says, what are some of the specific ecosystem service niches you've designed into your holistic management plan, ranching and home business philosophy? Spencer, do you want to address that question?
Yeah, sure. So we are trying to maximize energy flow being overall photosynthesis. And the way that we're measuring that is looking at that organic carbon or organic matter fraction change over time, because the more photosynthesis we get, the more liquid carbon we can pump into the soil, creating that organic matter, or that organic carbon. And so, you know, energy flow is a huge part of what we do as farmers and ranchers. And this is a way that we're trying to capture on a dry land basis in the Western Great Basin, how these different tools may or may not be worth the chips in terms of creating that benefit to the soil carbon. Biodiversity is always king, and when we planted both the no-till or the cool season and the warm season, they were very diverse. The cool season crops had you know, over 20 different seeds in that mix. The warm season, you know, was close to that as well. And I'll show you the warm season mix here in just a minute, and we can talk about kind of what we did or what we've been doing lately. What are some of the seeds that are coming up, and really what are some things that might not have started to materialize yet. So then the water cycle, also very important. We are taking, when we send those samples off to ward labs for the Haney test, we're getting back that aggregate stability and water holding capacity and a lot of that information. Again, wanting to see how effectively will our soil both infiltrate and then capture and hold on to that moisture over time, and how this is going to change. It's a pretty tough year to start that. I mean, we have had an incredibly dry winter, and then very sporadic. We did get some rain this spring, and we'd get, you know, a relatively decent amount for this part of the world. We might get an inch or something, but then it would be followed by 5 to 6 weeks of completely dry and unseasonably warm weather. And so it hasn't been really that good of conditions for you know, these new seedings that we've put in. But again, next year, time will tell what that happens, and we're collecting that in water filtration and soil data in such a way that we can compare irregardless to you know, winter snowfall and spring rains that we have in our cold Mediterranean climate. And then,
oh, sorry, go ahead. Go ahead.
The other thing we are continuing to measure and capture is mineralization, right? So the reason that we're taking those plant tissue analysis and the phloem analysis combined with all the soil tests that we're doing is wanting to see, gosh, you know, all this work that we're doing, are we able to increase the availability of certain minerals and nutrients for subsequent plants to utilize? And so, I mean, it's when you go out there and you take these soil samples, which Bree is going to take the second round of soil samples, I think Monday and Tuesday, it's a tremendous amount of work because we are collecting so many different samples, which is truly amazing, and definitely needed if we're going to have any scientific reliability to all this work that we're doing and the data that we're collecting. So hopefully, when we have the same conversation in 3 years or 4 or 5 years, whatever it is, we will be able to not only express what are we seeing on the ground in terms of forage production and profitability, but also how did these different specific actions increase ecosystems function or services.
Thank you, Spencer. I was wondering if we could give a little orientation to Springs Ranch. We did this in the videos, but I'm not confident everyone watched those, or maybe they forgot. But could you tell us where Springs Ranch is, the rainfall, you tell us about it?
Sure. So we are in Modoc County, we are as northeastern in California as you can get. You can basically see the intersection where California, Nevada, and Oregon meet from right here. And we're at the westernmost edge of the Great Basin. Cold Mediterranean climate, so we get basically, I mean, the majority of our moisture falls between December and the 10th of May. And so if you don't have a good winter, you don't have a good summer, because we really typically, if we start seeing clouds in July and August, we're more worried about smoke than we are rain, because you just don't get a whole lot of that summertime moisture. We typically get about 14 inches of annual rainfall here. So every drop counts, and we need to figure out how to increase that soil's capacity to infiltrate and capture that moisture for, you know, that July growth in subsequent years.
Thank you. And then we have a question from Marty. He says, how much soil organic matter did you have when you started?
Well, I mean, so Bree has taken soil tests from all over the ranch. On the study plots that are dry land, improved pasture that had been farmed pretty significantly, you know, over the last 40 years probably, in terms of grain hay, and then they'd go into a a different grain crop, or maybe a perennial grass hay crop for a little while and then go back into grain. Those ones, and Bree could answer that, didn't have a whole lot of organic matter, organic carbon in it when we started, compared to some of our pastures that had never been turned. They were up over 17% organic carbon, which kind of equates to right around 30% organic matter. So we've got some very high organic matter soils, and then when you get into the rangeland, you're typically 2 to 4. And I think this improved pasture that we were looking at, correct me if I'm wrong, Bree, was closer to that 4% organic matter.
Yeah, so I was trying to pull up the actual numbers. So at the 0 to 10 centimeter depth, we had a range from 1.37 to 7.08. And then the deeper, the 10 to 40 centimeters, 0.91 to 3.51. So yeah, I mean, we're looking a little bit on the lower side compared to some of the other fields.
Great, thank you. And Spencer, do you want to address the second question we have on the screen from our friend Todd, who came to one of our very first trainings? Do you remember that in Fairfield? Oh my goodness. That was years ago. So thanks for sticking with us, Todd. He says, do you interseed and with and when? Is there any rain after you interseed? I think you addressed some of those. And he's
so these study plots, we interseeded only cool season grasses just because we don't get any moisture at all in the summertime. And I planted those. The study design called for planting them in the fall, which was the intent. However, by the time I had to order a new no-till drill to do this project, or I shouldn't say had to, got to order a new no-till drill to do this project. And then also, of course, getting the seed. So the drill was about 2 months late in terms of being delivered, and I didn't want to order the seed until I made sure I had a drill to poke it in the ground. So as soon as the drill was delivered, I pulled the trigger on getting all that seed sent out. It got stuck in 3 snowstorms when it got out here, and so I didn't get it planted in the ground until the spring. I planted all the study plots in March, and we planted a pretty diverse mix of perennial grasses and a few annual grasses. We planted like a little bit of annual ryegrass and stuff like that. We planted a ton of perennial grasses, and then forbs and legumes as well, both perennial and annual. Be it sweet clovers, alfalfas, quite a bit of different things. And I'm happy to share, or when Abby sends the follow-up email with all this, I can add exactly what we put in all those mixes. And as we go forward. Here most recently, about 3 weeks ago, or no, about a month ago, I guess, I started sowing in with that no-till drill some warm season interseedings into some sub-irrigated and irrigated meadows to see what would come in. And those 2 different mixes I will absolutely be able to put on my screen and show in just a minute. Or I can do that now if this is the right time.
Well, let's do it in a moment. Yeah, go ahead.
So you can provide a valuable service to the rest of us in the West.
Yeah, those are just, that was just a comment. That was just nice of Anthony to say that,
gotcha.
Or for Todd, sorry, Anthony, sorry, Todd. So I think you've addressed the question. One came in from Stephen in the chat, and he said, during the dormant summer months, do you typically supplement hay or alfalfa, or do you have enough forage stockpiled? I gather interseeding the C4 covers in the summer is to make up for the lack of summer forage when all the C3s are dormant. How big are the study plots? And Spencer, can you explain what a C4 and C3 is?
Yeah, you bet. So let me a little bit more background. We're up here at about 5,000 foot elevation. So even though in the heat of the summer, we still have cool enough nights to where those cool season grasses or C3 grasses still hang on and grow a little bit. It's not like in the Sacramento Valley where it's truly dormant. This is our slow growth time, and we're kind of in that middle of that summertime slump. But our perennial grasses might have roots that go down, 10 to 20 feet. So we can still maintain green in these fields all summer, even on a dry year. So no, we don't have to supplement in the summertime, but we do supplement feed in the wintertime. And we stock the ranch accordingly so that, even within the summertime slump, we have more than enough feed to get us through. Yes, the point of planting the C4s or the warm season grasses, the difference in that is your C3 grasses, when they open up that stomata and take a deep breath in, they're capturing about 3/4 of the amount of carbon dioxide per deep breath, lack of a better term. That's not exactly how a plant works, but they open up to pull that atmosphere into the plant so they can pull the CO2 away from the oxygen for photosynthesis. Your cool season grasses capture about 3/4 of the amount of CO2 or carbon as would your C4 plants. This is very important because your warm season grasses have a different photosynthetic pathway than your C3. So it's kind of like a car with a 4-barrel carburetor, right? You stomp on the grass, more gas, more of the oxygen gets in there. That car can run faster or more efficient as to the amount of material that came up. So yeah, that's the difference between the C3 and the C4, and you're exactly right. I planted those C4 grasses and interseeded them into the cool season sod with the intent of creating that biomass on that 30 to 40 day slump when we've got daytime temperatures that are typically in the 90s. We planted a lot of different stuff, and when Abby gives me the go ahead, I can put those on my screen and we can talk about exactly what we planted and what I'm seeing germinate and what looks like it's doing well. And, gosh, some of the things that I had high hopes for, but I just can't find them out there.
Great, thanks.
And then my screen went away. I lost the slideshow that you had up.
Yeah, I chose to turn it off so that we could look just at you because we have some questions coming in from the chat and I wanted to address them. So okay. I think there's a whole portion, our video number 4 was all about the warm season interseeding. So I'd like to look at the list of things that you bought and planted at that point. But before we go away from the study overview, there was some questions about the methodology. Bree, so I thought you could help us answer this. Stephen asked, did you also do a PLFA test? And then Jenny asks, she's wondering how the greenhouse gas emissions were quantified. So those 2 questions, if you could address, Bree, please.
Mm-hmm. So we did do a PLFA, and right now, so we did that once in August of 2019. So we just have our baseline data on that. So not really much to compare it yet. I'll do another round of that in next week, and we'll be able to see some results. And then for the CO2 flux, so we partnered with Dr. Cindy Daly of Center for Regenerative Agriculture and Resilient Systems. She's out of Chico State University. And so they came up with a light core flux instrument, and we pound in these anchors throughout the study plots, 3 per plot, and then they put this big machine on it, and it can actually calculate right there in the field your CO2 flux. Unfortunately, when we did our baseline measurements, the data did not record, so we are redoing it next week. But luckily, with our study site being set up with control and study plots, we'll be able to still glean some good data from that. I don't have any, I guess, did that answer your question? Okay, Jenny, or I don't have any more specifics on how the light core works.
Yeah, we'll see it. Let's let Jenny can respond. Thank you for that, Bree. We can look, I guess another way to dig deeper into that would be to contact Chico State and the Center for Regenerative Agriculture and Resilient Systems. I was going to ask this too, and then Lori from our community asked, and she said, what does the PLFA stand for? I don't know that either. Oh, phospholipid fatty acid.
Phospholipid fatty acid.
Thank you, Stephen. Thank you, Spencer. Awesome. Great. And it's important to test for that to show the health of the plants?
No, phospholipid fatty acid is basically, and it's not as surgical as you'd like to think it is, but basically what it does is it's capturing the DNA of all the soil biology, or not all the soil biology, the main functional groups of soil biology that are in there, so that you can better track how your fungal to bacterial ratios are moving throughout this process, right? So as we increase soil health, we'd like to see a greater fraction of fungal types, not just mycorrhizal, but all different fungal types, because there is, their contribution to soil mineralization and plant health is, in the nitrogen cycle, and are a different level than is your bacterial. So the PLFA, or phospholipid fatty acid test, is really helping you quantify how you're shifting the community dynamics within the rhizosphere.
Great, that's great, thank you. Anything to add to that, Bree?
No.
Okay, great, thank you. All right, back to our slideshow. Can everyone see that? Spencer and Bree?
Yep.
Cool. All right, so our second topic was the compost application component of the study. And one question that came in from Craig Madsen, who's a fellow Savory accredited professional of ours up in Washington, a longtime holistic manager. And he asks, the level of compost you applied to the site at $1,200 per acre is not going to be financially feasible. Why did you apply that level of compost knowing it would not provide an adequate return on investment? Why did you not apply a rate that has a possibility of providing an economic return? Spencer,
so that's the good question, Craig. And to be honest with you, I don't know that it won't be worth it in the long term. The reason that we put down $1,200 per acre or 12 tons of compost per acre when we originally wrote the project plan, I think we put it down for 3 tons of compost to the acre, just for the issues that you're speaking about. However, the other compost research that's been done in California was based out of Marin County, and they use 30 ton of compost per acre. And since we don't have a nearby compost facility like you would in different parts of California or the West, since we're relatively rural out here, we had to ship that compost in from several hundred miles away, and we only wanted to do a one-time compost application. And that was the compromise that we could make with the Healthy Soils folks as to how much compost would be adequate for testing, basically what a one-time application would do over time.
And speaking of the application, I think you addressed part of Stephen's question when with the piece about it being trucked in. Maybe you could say where it was trucked in from, and then how does it compare to what happened with the Marin Carbon project and how that was applied?
Yeah, so they're basically applied the same way, except Marin Carbon project, as I mentioned, applied 30 tons to the acre compared to 12, which we did, which 12 is still a tremendous amount. We got the compost from State Line Compost in Merrill, next to Klamath Falls. And it was, the compost itself was a little over $30 a ton, cost another $30 to have it shipped home, and then about another, $30 to have it spread, by a local contractor. So that's why we got right up to that $100 a ton by the time it was put out and everything was done. It came to right about $100 a ton, or $1,200 an acre. But as we mentioned, Craig, to whether or not it's financially feasible, yeah, this year we didn't see a dramatic increase in forage production. Being a dry year, the compost was put out in April. We had an extremely dry April. And then we really had a really dry year after that. So we didn't get to see that big bounce. However, it'll be interesting to see how mineralization and how improvement carries on after that and really whether or not it's worth the chips. Because I'm with you, I'm very skeptical of an investment of $1,200 per acre, which on these kind of dry land, improved acres in this part of the country, the acre's not worth $1,200. So basically, we're putting the cost of buying an additional acre on top of it for the benefit of improving production. Personally, would I rather have an additional field, buy more acres, or put down the compost? That's really what this study is developed to find out. If compost applications in this particular area, is a financially reasonable project or prospect.
Great, thank you, Spencer. Bree, is there anything that you wanted to add to that?
Well, I would just add that how we came up with that 12 tons per acre was that we wanted to go above what the current research recommends for rangelands for compost application. And so 12 tons per acre is 50% more than the current recommendation. And in the hopes that we could see, okay, if we apply this one time, 1 year only, due to the fact that we have to ship it in and that's the expensive part of it, like, could we see any benefit from it? I don't think, 12 tons an acre every year is feasible at all. But we're hoping maybe we'll see some sort of increase that lasts more than a year. We'll see 3 years, 5 years. So that's kind of how that number came about. But I agree, it is, pricey. So we'll see what happens.
Yeah, great. And before we move forward with the conversation, I wanted to go back to our bacterial to fungi ratio. Another question from Jenny. She said, what were you hoping for in that ratio? And does it hold true for just rangeland or all soils in general? Does that make sense? Because there are universal bacterial to fungi.
Yeah, so there.
Thank you.
Right, so there's a correlation with your fungal to bacterial ratio and which, right, so nitrogen cycle, as the nitrogen goes into the soil, it's constantly unwinding, right, from ammonia, nitrates, nitrites back up into the atmosphere. Different soil biology capture that and make that nitrogen plant available in different ways. So it kind of stalls out or will allow those plants to get that nitrogen different ways. And so if you're in like a closed canopy forest system, your fungal to bacterial ratio could be like 1,000 to 1 fungal bodies for every bacteria, compared to like a rye field in Fort Bidwell, or fungus to bacterial ratio or bacteria over fungus might be 500 to 1,000 to 1 more bacteria than fungus, because your annual plants really, really thrive on that simpler soil and need that bacterial collaboration versus less of a benefit from the fungal bodies. We are here trying to manage for perennial grasslands, which is about that 50-50 mix of fungal to bacterial ratios. But then we also want to see an improvement in mycorrhizal fungi opportunities and connections. So really, there is no target as far where you want to be, and as far as that fungal to bacterial ratio, so to speak, carte blanche. More you're tailoring it to, okay, I want this to be a perennial pasture, so we're going to go this way. Or I want this to be an annual, small grain crop, so that's why I might choose a different action like tillage, which is going to aerate that soil and disrupt and kill all that fungal hyphae and really create a lot of opportunity for bacterial bodies in it. And so, you want to disc it up and create that fine seed bed to plant your oats or your corn in. But you wouldn't want to create that same soil profile for planting perennials, right? Or trees or something like that, because that's kind of why you want to watch that. So we haven't taken any actions specifically for shifting the bacteria to fungal ratios, we're wanting to see on the, you know, kind of like flipping that coin over, we're wanting to see, okay, what does a compost application do to fungus to bacterial ratios versus planned grazing versus, you know, interseeding versus a combination of interseeding and compost. So that portion of it is really truly looking at how all of these things that we all have the opportunity to do as farmers and ranchers are really shifting that microbiome in the soil, and is that going in a direction that is going to be producing the health that we're really after.
Thank you, Spencer. And then one last question on compost, then we need to move on to our other two topics. Marty says the value of compost application down the road could manifest itself as an increased soil water holding capacity, carbon sequestration, or even nutritional quality of the cattle. Are you looking at other metrics aside from forage? I agree with those points.
Yeah, absolutely. And that, to Bree's point, when she was talking about that in the beginning, that's why we're doing all the PLFA fatty acid tests. That's why we're doing all the Haney tests and you know, taking the tremendous amount of soil samples and sending those off, is to figure out truly, and it, you know, we don't know what's going to happen. So it may be that our water holding capacity over 3 years after adding that compost, just, you know, we find out, yeah, it's definitely worth the chips because our organic matter went way up. Or we might think, gosh, that was $1,200. I'll never get back on that acre. And so, yeah, I mean, in true scientific form, that's why this particular project has a 3-year lifespan on it, and hopefully we can continue to track that information past 3 years to see just exactly how long, if there are any benefits, how long are those benefits lasting us into the future. So that was a fantastic point by whomever it was that asked that.
That was Marty. Thank you, Marty, for that. Just a couple of questions, because I love the comments that are happening. And Stephen says, yeah, but you also get organic carbon capture via root exudates, not just via decomposition. And Marty says the PLFA.
Yeah, that's exactly right. And that's why we're measuring energy flow and overall photosynthesis, which, you know, all those things are connected, right? You can't get photosynthesis without water, and trying to continue to make that happen. And so root exudation, you know, liquid carbon pathways as far as a method for building soil health and overall water holding capacity and aggregate structure is huge. You know, and so that's more like Christine Jones's work and all the research that she has done. On the other side of the coin, you've got your decomposition pathways, which would be like Elaine Ingham and all the work that she's doing. And, you know, there's so many other soil scientists that are finding out how to create these benefits through both of them. And really, at the end of the day, we need both decomposition pathways and liquid carbon pathways to build healthy soils. The redundancies in nature are of such that, you know, it's not really either or. We're trying to maximize the amount of litter that we can lay down and the health of that soil microbiome so that it can consume that litter in a fast enough time period to unlock those nutrients for the next crop or the next group of plants. So we don't have oxidization, basically releasing all those nutrients in the atmosphere.
Thank you, Spencer. So we only have 15 minutes left, so I want to make sure we have time to get to video 3 and 4, the topics of those. So video 3 was so fun. It's all about dung beetles, which we're so passionate about here at the Jefferson Center. So the first question that came in was regarding worming medicine administration recommended during the winter, because Spencer said that's, in the video, he said that's something you can do if you must, an action you can take and protect your dung beetles. The question is, how does it given during the summer months affect or kill the dung beetles? You want to explain that briefly, Spencer, and then we can jump into a couple of questions from the chat.
Yeah, so just for a little bit of clarification, we're organic here, so we don't use the wormers, period. However, since we're at 5,000 foot elevation and it gets super cold here, dung beetles being an insect, you know, and cold-blooded critter, they're not out during the wintertime. right? So you typically, after you worm a cow with like ivermectin, you get about a 30-day blood level of that medicine inside the cows, and then they will kind of shed that medicine in their manure for 30 days. So in the summertime, if you worm your cattle with ivermectin, you've got about 30 days to where that wormer is going to be in the dung pats that the dung beetles have to feed on. Now, there's a lot of research, and there's some wormers that say that they're not as detrimental to dung beetles as others. And you really got to look at that information when you're picking your wormers and your time to worm, because a lot of that stuff might have a little asterisk next to it, depending on how those wormers work. So in the short term, if you worm your cattle, say like in June, the dung beetles come out, yeah, you might not see a whole lot of dead dung beetles if you're using a product like Dectomax. However, those dung beetles' eggs will be sterile. So they'll still make the brood ball, they'll still bury the that material into the soil. However, nothing's going to hatch. So your population of dung beetles, since they're an insect and relatively short-lived, spirals downward. And so, like I say, we believe that dung beetles are a keystone species here, and so we're doing what we can to promote them. And that includes, increased grazing management, and then also not utilizing wormers for the benefits of those guys.
Thanks, Spencer. A question for Bree, the couple around other biodiversity measures. One came from Gail. She said, what other biodiversity measures were being measured? Birds, dung beetles, soil biology, fungi, bacteria. And then similarly, I think it's Julio asked, are you looking at other invertebrate species apart from dung beetles?
Yeah, so unfortunately, we're only looking at birds, dung beetles, and the soil biodiversity. We would love to look at, as many things as we could, but just time restraints for data collection, we're already kind of maxing out. But I think, looking at those different biodiversity measurements will hopefully give us kind of a little bit more of a picture into the biodiversity. And it's interesting. I've been thinking about like some of these measurements we're doing, and like the bird data, oftentimes like the bird populations we're looking at, they're, spatially birds for breeding and brood rearing are using landscapes larger than our study plot. And so it's really the data we're collecting there is going to give us just kind of broad scale picture of what we're doing. But yeah, if anybody has any ideas of any other cool biodiversity things we could look at, I'd be interested in chatting about that.
Awesome, thank you, Bree. And yeah, the biodiversity is so fun. It's such a fun part. So I don't want to move on too quickly. If there are other questions, please do enter them in the chat about biodiversity and about the amazing dung beetles. So our video 4 was this warm seeds and interseeding, and I wanted to give Spencer a chance to share with you the actual seeds that he purchased. So maybe Spencer will do that and then get to the questions here. Just one is about an update to the risks and challenges that were described in the video. How is that going? And then the other is about this idea that we've been discussing with Byron Palmer, our friend at Grounded Grasslands, about the state of the annual California rangelands that are so near and dear to our hearts, that they really need more than grazing. That's at least what some studies have seen. And so I know that you've spent a lot of time on California rangelands doing EOV installations. So we just wanted to see what thoughts you had on that. So, but before that, I'm gonna stop sharing my screen and let you share yours to talk about the C4 mix that you bought.
Shoot, I don't know where it went now. Let's see if I can find it.
Looks like you started sharing your screen.
Yeah, but I think I'm on. How do I move this thing out of the way? So I can click on grass seed mixes. There it is. Okay, can everybody see what I'm looking at?
Yes, we can.
All right, fantastic. So for my warm season that we just planted here about a month ago, we planted 3 different test plots. On each of those fields were about 30 acres. Now we're looking at sub-irrigated and kind of irrigated native, so it's not necessarily native, but virgin ground that has never been turned. So it already has a pretty robust cool season component to it. But as the previous person asked in terms of their question, that summertime slump and what are you going to do about that? So I sat on my tractor for a few days and I shotgunned in or interseeded guar, sun hemp, soybeans, cowpeas, mung beans, popcorn, Jap millet, sorghum Sudan grass, pearl millet, sunflowers, okra, pumpkin, safflower, buckwheat, chicory, plantain, small burnet. Into one 30-acre pasture had that. The other 30-acre pasture or another 30-acre pasture had all of these less the sorghum Sudan grass. And I wanted to have a pasture that didn't have sorghum Sudan grass interseeded into it because I was concerned about prussic acid issues and wanted to see really if having that sorghum Sudan in those pastures really was worth the chips or, worth the risk, I guess. Is the juice worth the squeeze in terms of putting that seed into those pastures? Of those fields that I put in, I was super excited about like guar and sun hemp and some of those really, really robust legumes and seeing what they could do. And unfortunately, I really haven't seen them. Haven't seen them come up at all. However, the soybeans and the cowpeas are coming up pretty good. And actually, of all of the things that we planted down there, the thing that surprised me the most and is really doing pretty well is the okra. So again, that particular field is only about, this particular field is only about 3 weeks in the ground. And so these plants are, they're not as well established as I would have hoped. But the ones that are established, they're 6 to 8 inches tall, is all. And so hopefully, as the summer continues, they'll really start kicking in and start to really develop. The plantain and chicory is also coming up and doing fairly well. Didn't have any luck at all with the corn and some of these other grasses. Millet, haven't seen the millet come up too much in those 2 particular study plots. And then sorghum Sudan grass, at this stage, I can't tell if it's one of the grasses that's coming or not, but even if it is, it's not coming up at a good enough quantity to make it worthwhile. Really the only stuff that's really coming up in an exciting way, I think, is the okra, and then like the beans and cowpeas and things like that.
Right.
The other field that we did, so we did 2 of those 2 pastures or study fields with that more expensive mix. Uh-oh, did you take away my screen?
I did. We only have about 6 minutes left, so I wanted to carry on. But yeah,
all right. Well, there's another mix that I put in there that was a little bit more affordable. So that big diverse mix was pretty expensive, but I wanted to see, since we've got all this study money to utilize, I wanted to throw as much out there to see, okay, of all these seeds that we put in the ground, what's actually going to make it worthwhile. On the other side of it, I want to see, gosh, if I'm doing this on my own budget, what is a cheap way to get some good summertime forage established? And so I put in another 30-acre field of just Korean Lespedeza, crabgrass, and Japanese millet. And the crabgrass and the Korean Lespedeza are coming up. Like, you can go out in those fields and you can easily see where all those coulters and cedars went through the ground. Not the biomass that I would have hoped after 3 weeks or a month of being in the ground. However, definitely a lot of seed germination, and I'm hoping that as summer continues, those plants will really start cranking and making some good feed. But that particular, of the two different things that I did, just the crabgrass and the lespedeza, in terms of how well it's germinating and doing, I'm pretty excited about that.
Okay, thanks, Spencer.
And then,
We only have a, sorry?
okay, so the next question that Byron was asking, regarding California lands being so degraded, not being able to sequester carbon with grazing alone. Man, I'm not seeing that. Richard's grass-fed beef, or Carrie Richards in like the Marysville area, with nothing more than grazing, is killing it. Like, she's got some of the best soil carbon shifts, period. And she's just utilizing grazing at the right time and, leaving adequate litter on top of the soil so that it can decompose and turn into that soil carbon. Largely, she's utilizing decomposition pathways. However, as she, over the last 3 years that I've been monitoring her place, I've also seen a tremendous amount of perennial grasses that she hadn't ever planted, just stuff that was native or already in that seed bank that's coming up, which is really going to increase that liquid carbon pathways and getting that soil carbon kicked up down deep. So I think that it is a bit short-sighted to say that grazing alone can't improve California rangelands. I think it's going to have to be really good grazing to make that difference happen. And then we're also going to have to look at the quality of the litter that is being laid down. Like, what's the carbon to nitrogen ratio of that litter when we graze it, so that it can, so that there's enough protein or nitrogen in that litter to foster rapid decomposition pathways, so that that soil carbon can actually go in the ground versus just right back up into the atmosphere. So if we got too big of a spread between the CN ratios, a lot of that carbon is going to be lost back up into the atmosphere versus decompose and be brought down by all the little critters that do the hard work to the soil.
Thank you. I think Byron will be really excited to hear that. He was so concerned about that. We have about 2 minutes left, but I'm hoping that everyone will stay with us another few minutes so that we can wrap up and get some last few questions in. Let's see, we have some. Anne asked if any microbial inoculant was used on the seeds, and then Stephen asked, did the cattle like grazing all these different species, or do cattle like them?
Yeah, we're grazing at high enough stock densities that cattle are eating everything. And, we'll continue to do that because we're wanting to leave a pretty good trample and litter profile on the soil surface. But yeah, everything that we planted was good cow feed. Yes, we did inoculate those seeds. Typically, it was just, not typically, the legumes were inoculated with organic or armory coatings that had the correct biology to make that that nodule release that nitrogen into the rhizosphere. So yeah, we did use some inoculations. Oh, and also mycorrhizal fungi inoculant was also in the mix on both of those. And it was just a regular broad or common strain of mycorrhizal fungi that was added. So that'll be interesting to see how our PLFA tests shift over time by inoculating those soils with the fungal attributes.
Interesting. Anne says, fantastic. One last question from Marty. He said, did you have test plots, and this can be a question for Bree, do you have test plots on your high organic soils? Do you expect that they will be able to add additional carbon? CDFA and NRCS, that stands for the California Department of Food and Ag and the Natural Resource Conservation Service, their government agencies, doesn't allow funding of compost application on soils greater than 20% based on the expectation that there won't be additional value. Bree, do you have thoughts on that?
So our highest soil organic carbon study plot was the 7%, which is actually pretty high for a lot of these fields that we're working on up here, a lot of the rangelands. That's just kind of what we're working with. And so, I mean, I don't think I've ever seen one up here with 20%. Have you, Spence?
Well, didn't you, the first Point Blue data that you reported on a couple years ago at that field day, didn't we have 17% organic carbon?
You're right, we did. That was in one of the
not the study plots, but in the meadows.
Yeah,
right.
That was in one of the nicely irrigated bottom fields. So yeah, so I mean, what was the question, Abby? Do we expect to see
further? And so I think if I could jump in,
sure.
I think looking at, so there's almost a point of diminishing return, right? So if you get up over 30% organic matter, your mineral component of that soil is obviously not as high. And it's not like a point of diminishing return. But yeah, if you continue to just look at 0 to 10 centimeters or 10 to 30 centimeters, 10 to 40 centimeters, and that soil health becomes, to that point where like that sigmoid curve is starting to flatten out a little bit. If you were just looking at that at face value and trying to infer whether or not continuing healthy soil management is smart or not, might not show you a big enough picture. Because really what we're trying to do is not just enhance the soil health in that 0 to 10 or 10 to 40 centimeter strata, but I want to make that tilth of that rhizosphere go down all the way to basically the water table, right? Where there's no more oxygen, and that's going to stop you from having, because it's anaerobic, you're not going to have the biology to create these dynamic connections. So no, I don't think there's ever a point when you can stop making your soil healthier. If you get stuck in a box and you're only looking at soil at a certain depth, certainly you're going to see points of diminishing return on how much additional carbon is going to be stored. However, you have to remember that as that carbon in that soil improves, it's building that aggregate structure. So kind of like, think of it like baking a cake or baking bread. If you take all the carbon that's in that flour and you dump it in the bottom of the bread bowl when you start, you might have that much flour at the bottom of your bread bowl. But then you add the yeast and the biology and the water and all of the things happening, whoop, now it all rises and you bake it. So now we've got something that if we were just measuring the original 0 to 10 centimeters or 10 to 40 centimeters and that soil's completely compact, and it said we had 5% organic matter. And then we come back a decade later and we measure that same strata. Well, that's not a fair comparison because now that bread hasn't had a chance to rise or that aggregate structure has had a chance to develop. And so now we're not looking at that same 0 to 10 or 10 to 30. Now that soil profile has truly increased because of aggregate development and basically the life and the tilth in that soil is now increasing basically in elevation. So yeah, you can always continue to improve your soils in terms of carbon and health.
Right.
And those two things, that's not synonymous, right? So carbon is a great indicator of health, but it's not health in of its own.
Yeah.
Right.
A whole nother topic. Bree, did you want to add to that?
No, that was really good, Spence. I like your analogy.
Yeah.
Thanks.
Cool. Well, we are at the end of our time together, and what I'd like to end with, and thank you guys so much for staying extra, we have a poll, and this will help us so much understand you better. It will help us be able to develop content for you that's what you want. So you should have a poll that has been launched in front of you called the Virtual Ranch Field Day program. And if you could please answer the 2 questions that are there, basically how you would identify yourself in this setting. So did you come wearing your hat of a consumer that cares about food that comes from regenerating soils? Are you a researcher? Are you a land manager, a student, or farmer, rancher, or maybe something we haven't classified? So if you could let us know, it helps us so much. So we'll give everyone a minute or two to take the poll, and then we'll talk
So
about
we click this poll button at the bottom. Is that what we're supposed to do?
No, you don't touch anything.
Oh, because I'm not seeing anything on my screen.
Yeah, I think, yep, because you're a host. Don't worry. Everyone's taking the poll.
Oh, sorry.
Yeah, don't touch it. Just don't touch it.
Hey guys, while you're doing that, these are really fun conversations for me to have. So if you want to, like if something's not clear or you just want to have a conversation because you're still curious or you want to figure out whether or not any of these actions might be worth the chips on your place, feel free to give me a call. My number is 775-221-6793. And like I say, I can geek out on soil stuff to no end. So as long as I got a willing participant, I'm always happy to have that call.
Awesome. While everyone's taking the poll, let's just look at some of that contact information. So just wanted to say, again, a big thank you for everyone for being here with us. It's so fun to talk to you. And this also goes for everyone that registered for this webinar that couldn't be here because perhaps it's 2 a.m. in Australia or it's, midnight in Germany. But we had so many people from around the world join, which is a great part of being part of the Savory Global Network, and we're very grateful for that. So like Spencer said, this is just part of the conversation. This is year one, this is a 3-year study. There's so much rich information here, and our whole intent with doing this study is to share it with you and to learn together. So as Spencer said, he loves to talk about it. Please give him a call. You can also route that through me. My information's there through our website. And then Bree, our amazing research partner, her information is listed as there as well. So yeah, we just, again, are so grateful for everyone and just wanted to let Spencer or Bree share any closing thoughts.
I just want to say thank you, Abby and Spencer, for letting us do this on your place and try out all these kind of new things. Also, yeah, if anybody has any further questions or thoughts, I would love to chat with you about it, and hopefully we can keep going on this research study and start a phase 2. So any good ideas, send them my way.
Absolutely. And I just wanted to also thank you, Bree, and make sure that everybody who is on realizes what a great resource Point Blue Conservation is. So if you are a land manager in the Western United States and you want access to some pretty darn good scientifically robust monitoring, Point Blue is a great way to go through it. And it is, they do a fantastic job looking at a whole host of different ecosystem indicators, and they work throughout California, certainly, through all your NRCS offices, through partner biologists like Bree. So thank you so much, Bree, for all the work that you're doing, and I hope that this meeting will create the opportunity for more ranchers and farmers and land managers to reach out to Point Blue and utilize your guys' important services.
For sure. Wonderful. Well, thank you, everyone. Thanks for spending part of your Friday evening with us. Have a wonderful weekend, and please stay in touch. We're really grateful for all of you, and have a wonderful night. Bye.
Bye.
Thanks. Bye.